All right. Okay, before actually jump into today's session, let me give you one. Today I'll give you one assignment to you guys. I will announce one assignment. Just it is not an assignment type. It is kind of a reporting type. I'll give you just for extra credit. You may get maximum 10 points. So please try to do this. It will be nothing but that from the beginning till today that you learn. Write a report on it. 5 to 7 pages should be fine. Any format, 5 to 7 pages. That should be fine. You may get maximum 10 points. Okay. Okay. So I'll give you an announcement after after today's class. Okay. Before we start, let me share my screen. All right. Let me turn off my video. Clear till here. Let me slide. Give me a minute. All right, last class we talked about the open system call. We already know this create system call. When you save a file, for example, when you save a MS Word file, then your MS Word software will actually make a system call. It's called create system call when you save a file. But when you open a file, for example, by using MS Word, this MS Word software will make a system call this open system call. We already talked about open system call to open a file. And not only this MS Word software, if you go for this, if you try to open a file by using this Google Doc, it will make this software also make this similar call. This is common for this the kernel function or system function. So to open a file by using any kind of software, it makes a open system call. It will make open system call. Also, that when you save a file, it will make a create system call. When the create system call will make create system call will make several steps. At first, it will make this file that you want to save in different in blocks. In blocks, this is also same size of blocks. It is 512 byte usually. Also, in next step, create system will just store this file block to the SDD hard disk drive. SDD drives. This block size is also 512 byte usually, but it is, you can see it is same as this block as well as the file block, and also hard disk block is same size. This block size is same, and then after this, then the create system call will make this file in different divided into different blocks, and then this block will be saved inside this SDD blocks in next step. This is 1, 2, 3, 4, 5. 1, 2, 3, 4. This is 5 blocks. This is stored. Let's in here, and then next step it will manage a. It will make entry to the file directory tables. It will make entry to file directory tables. So each file it maintains. If you open any file, it will maintain the file directory tables. File directory tables usually contains many. Each row actually particular. Each row represents the for a particular file. So file directory table contains the file directory table. Actually, this file directory table, a number of rows is equal to the total number of files inside your computer. So there are lots of entries in here. Okay, you know that in your computers there are several entries, lots of entry. So lots of files. So each file has its one entry or one row inside this file directory table. So also file name and location, these are two important parameters. Also size of a file, and then the as column, and then it can be the number of blocks of a file, read date permission, everything maintain a file directory table. Okay, file directory table for a particular file. So let's say file F1. So here, after this storing this file here inside this file directory table, it will make an entry for this file F1. But it will make this file name in here also location. Location is kind of, this is 0 number block 1, 2, 3, 4. This is 4 number block. So 4 will be here. Starting block. Starting block means where this 0 number block of file. This is 0 number block of file 1, 2, 3, and 4 number block of file. Actually, you need to track this where 0 number block you load it inside this SDD. Also, you know this block number for file block number is called this logical block number. This is logical block number, and block number inside this hard drive is called the physical block number. 7, 8, 9, 10, and so on. This is physical block number. So logical block number 0, logical block of 0 is stored in physical block number of 4 of hard disks. Okay, from this 4 number block, 0th block of file is stored in 4th block of SDD. So logical number, physical number 4 is stored the 0 number block of file. So this is 0, 1, 2, 3, and 4. Total 5 blocks. This is contiguous allocation. We'll see the non-contiguous allocation as well. So file is stored is block is adjacent block. So total 5 block in a file inside a file. So it's about it's stored in a contiguous location inside a hard disk as well. So location will actually refer this where the 0 number block of file 0 is stored inside this hard disk, and from this location you can identify every block of a particular file. Okay. Also, when you make this open system call, when you open, then in open there is two there is two table also maintained inside this SDD. One is one table is called, when you make, this is for create system call. Create system will create this divided this file into separate block and store it inside this hard disk and make it and gives an entry added an entry inside this file directory table. These are the steps for create file system. And when you open a file, it will make this open system call. Open system call will maintain two tables inside this RAM. This table, this file directory table is permanently inside this SDD, inside your SDD hard disk drive. But when you make this open system call, it maintain two tables inside this RAM, but it is not permanently stored inside this hard disk. This is maintained inside this RAM. One file, you know, I already showed it. This one file is per process of open file table. In our last class, we saw this per process open file table, and here it takes one is called this first is called this logical. Let me remove this line. Logical byte number to be accessed. Actually, which logical byte number wants to accessed by the CPU from a file. Okay, this is the logical byte number wants to be accessed. This column maintain these things. Another is pointer. This next is pointer to the system wide. SW refers system wide entry. Where is the system wide entry? System wide entry is nothing but another table. This is called the system wide. Another table is maintained inside this RAM, and this is called the system wide open file table. So it's maintain the name of a file, just one, the entry similar entry as the file directory table. Just it takes in here name. Let's say only two column I show here, name as well as name, and then location of a file. Location of file. This is 20. Also, it contains some other entry as well. It could be size as well, number of blocks, some other entry as well. Whatever you saw in a file block, in a file control block. the size as well as the permission, and then size, permission, and also number of blocks of a file. This entry also contains the file directory tables, also the system-wide open file as well. Let's say what is the difference between file directory table and system-wide open file. So when from the system-wide open file, these two table, as I mentioned, this table maintained inside the RAM, inside the memory, but this table is permanently stored in SDD. You know, this file directory table is very big. This number of entry depends on the number of file inside your hard disk. In your computers, over kind of millions of files over there. So there is millions of entry in here. So system-wide open file refers that at the current time, at the current instance, how many files actually open by separate process. This process is nothing but a software or program. So these things maintained by the system-wide open file. That now, let's say by using this MS Word software, you want to open this file F1, you click this file F1. So this is MS Word software. When you open, so it will make this MS Word one process. So it will create a, when you open, it will make a open file call. In open file call, what it will do, it will search this what file you want to try to open, and then it will manage these two tables. Logical byte to be accessed. At first, you want to access to the 0th byte, and let's see that. And then what it will do from this file directory table, it will take this, it will search this, where is the file F1 entry. So it will find this file F1 entry, and F1 is location is 4, so it will take this F1 and then store, and then location will be stored in here. Location will be stored in here. Just one entry it will take pull from this file directory table. Which file actually wants to open? This entry from this file directory table. This entry will be actually inserted inside the system-wide open file. You know that file directory table is very big table. If you take this whole table inside this RAM, so this size is very big. So memory will be the wasted. So whatever file is open, this entry will be added inside the system-wide open file. It will reduce the space. It will reduce the space as well. Okay. And this is you open this for file F1, and then system pointer to be SW entry, system-wide open file empty. So here is a pointer. It maintains where actually you open this here. It's point to this place. Okay, this place. This is a pointer. Point this when you open this, or where actually F1 actually located for system-wide open file table. So it's this pointer actually refers these things. Now let's say if you open some others file as well. If you try to open by using this let's say Google Doc software, by using this Google Doc, you want to open some other software called this, let's say file F2. So when you click this file F2, then this is a process. Google Doc is also process. Amazon is also process. Also, we can for understanding, we can say this software. When you click this Google Doc to open this F2, that first what it will do? It will search this system-wide open file, figure out this whether this file F2 is opened by some other process or not. If it is not, then it will search this file directory to take this entry for F2 table, F2 file. Let's say F2 is in here and its location, let's say 100 number blocks. So it will take this F2 and move it to the system-wide open file table. So F2 in here and its location is 100, block number 100. Okay, this is how it's works. And let's say by using another, let's say OpenOffice, by using OpenOffice software, you try to also open this F1 file. You know this by using two different programs or two different processes, two different software, you can open the two files together. Sorry, same file together. By using two different software. So MS Word also open this F1. Also, you try to open this OpenOffice. By using OpenOffice, you also open this file for F1. So what it will do? It will check this in here. In here, this F1 is already open or not? Yes, F1 is already open. So what it will do? This is per process open file table. So every process, Google Doc also maintain one per process open file table. Also here OpenOffice also maintain per process open file table. What is per process open file table? It will maintain these two things. One is logical byte number to access, and another column is pointer. Okay, pointer. This pointer, I make it short in here. This is pointer in here, and then what it will do? Also this pointer, this is logical byte number. This is 0 wants to access 0 bytes want to access byting for file f1. Also pointer is where it will point. It will point the same location at same pointer. Sorry, same pointer. Let me. It doesn't work in here. Let's say just remove some part. Then it will. Let's say for this is for open office. Open office. But in this open office, he wants to open this file f1 as well. File f1 as well. File f1 is in here. Let me make it different. F1 here. Also f1 opened by MS or software also here. So it is also inside this system-wide open file as well. So by using open office, you try to open this f1. So at first, what it will do, it will search that this f1 file is already opened by another process or not. If it is opened by some other process, so entry should be the system-wide open file table that is inside this RAM. So it will search this system-wide open file table, and then it will find this F1. So what is the advantages here? Actually, this open office software actually needn't access the file directory table to the SDD. You know, this to access this SDD takes lots of time compared to the access to the RAM. So it will actually save some running time. Okay, then F1 is already here. So OpenOffice is maintain also these two data logical bytes to be accessed, and also this SW pointer where this system-wide pointer is in here. So logical byte number is accessed, let's say 0 also in here, and pointer will be the same pointer as in here. F1 pointer is point in here. Okay, from this system-wide open file, you can see it will just use this data. This where is this logical, where is the location for this file? First block of this file. Where is the first block of this file? It will get this information from this table. So by using this table and also this MS Word software also point to the same data F1 data that is collected from this system file directory table. Okay, so in a summary, when you go for this open file call, here is maintain this two table. One is the per process open file table, and also system-wide open file table. And first, it will search this file is already opened by some other process. If it is open, then it will be the system-wide open file, so it will point to this file location. If it is not, then it will take this data from the file directory table. Okay. Now let's see what is the next step in here. Next step, you see that why. From here you can see that how many files is currently open. By using the system-wide open file, you get this idea already. So why is per process? Why it is need to maintain by this per process open file table? Why you need to maintain? Okay. Now let's see for this. After open a file, what you need to do? We usually open a file to do either read or write operation, right? This is why we just open. When you open, you just read the data from this from file, or after this open, then what we do after this open file, we just write and edit and write some data. So read write operation we do by using this open system call. So next to system call is to process. After this open, there is another two system is called this read system call, and that is called write system call to read the data and write the data. Open will make these two tables. Just open it, and then after this open, then open system call, it will make either read system call or write system call. These two things you will do actually perform usually. So how actually when you open a file using file F1 file name, this open file is return a pointer. This pointer actually is a parameter for a read file and also the write file pointer. Okay, write file. What is the pointer? Pointer points this where actually F1 data. Where is the F1 data inside this per process table? The per process table, there are some entries because one MS Word software can open 2 or 3 files. So where actually this file F1 actually located. So F1 located this pointer. So by using this pointer, read take this pointer, actually figure out this, where is this location in here, called F1, this location. Also write whatever actually similar thing is done by this read date operation. So write also by this pointer, it maintains the same thing. Let's see this read operation. Read date operation actually it's do the same thing. So if you understand the read, then write also do this actually do the similar way. You can do this write operation as well. So let's see the read operation. After this open, you do this read operation. First, you wants to read the byte number here, 0 number byte. So in 0 number byte, and then what it will do, it will see the your CPU wants to ask for the 0th byte. First, you figure out that this logical block number for this 0th byte. Actually, at which logical block is file block, logical number for this file block. This which logical block actually 0th byte is available. So how we get it? You get it this byte number divided by size of a block, and floor it, then you will get it floor, and then it get it. It is kind of this requested byte. It is 0 number byte divided by the block size is 512 byte. Okay, this is 0. Okay, this is 0. So in 0 number block, file 0th byte is available. So it will get this 0 number block in logical block. This is logical block, not the physical block. You get this logical block of file logical block number where is 0th byte is available. So from this logical block number, what's it will do read operation? Then it will point out where is this 0th actually sorry 0 block is 0 block for this physical block number. So 0 block is for this physical block number is 4. From here you will get this number 4. So at 4 actually 0th block of this file is stored. Okay, stored at the in here actually is stored. File is stored at 0 number block is stored at logical block file. So from here you will get this information. So this logical block 0 number block, logical block 0, but it is stored inside block number 4 at physical block number. So this block also take by your operating system, also put it, this read write operation done by this block wise, not a single byte. It won't take here from here, it won't take only the 0th number byte, it won't take only the 0 number byte. All 512 byte block actually store inside this RAM, and from this RAM your CPU get this 0 number byte. Okay, now let's see this another example. Let's say your CPU asks for 0 byte number 600 byte 600 byte instead of 0. Let's say 600 byte. So where is this byte is available? How you get this? With which block number it is available? So you just go for 600 divided by 512 byte, and then it will be the 1 point something. If you follow it, then one number. So from here you get this one number logical block, file logical number 600 byte is available. Means this block in this block 600 byte is available. So and then actually where this file block inside this hard disk, you will get this 0th number block just plus the logical block number plus 1. So 4 plus 1 5. That 5 number block you will get this 600 byte. Okay, 600 byte. Okay, this is how actually read write operation perform. Okay, now most of the cases actually read write actually perform by using continuous actually read write perform, continuously read write perform, sequential read write perform. It is not random. Sequential means that when you read a file, open by using MS Word file, it just reads 0 number, then 1 number, then 2, 3, 4, and so on. Every byte it read by sequentially reading. But in some instance, there could be the randomly reading from a file. Okay, First, they may ask for the 0 number byte. CPU asks for 0 number byte. Then it may ask for the 1000 number byte. This, and then it may ask the byte for this 3000 number of byte. This is how it can work. So one byte can be in first block. Then it asks for another byte. It can be reset number 10,000 number of block. So it can be. This is actually known as the random access from this disks. Random access from this file. We'll learn more about this random access. Just give the heads up. Now you can see that this is how this is the logical block number. So why it needs to maintain per process wise. Let's say you open two files F1 by using this OpenOffice as well as the MS Word software. This is for OpenOffice. You open this F1 file by using OpenOffice as well as the MS Word software. F1 file F1 also it's point to the same, sorry, F1 also point to the same location, this location. From here it will get the 0. Where is the 0 number block? Where is the 0 number block of file is stored inside this hard disk? It is 4 number, physical number 4, it is stored, okay, in our example. So let's say you open this file F1 by using this MS Word software, and MS Word software, this is scheduled by your operating system. So it's start reading, and then it start reading and completes its reading till 1000 byte, and then next it will access for 1001 number byte. Okay. Now your CPU schedule the OpenOffice software, and then OpenOffice software also start from the 0 number byte, and then 1 2 3 4, and it till, let's say, till it is read till, let's say, 500 byte, till 500 byte, then it is stopped. 500 byte, then it asks for 501 byte to access. So here is 1001, here is 501. So you see, this can be always mismatched because this process is scheduled by CPU little bit less time than the MS Word software. So MS Word did more byte sorry, than OpenOffice software. So this number, which byte will be the next, it depends on this process. How it is scheduled. So these things you need to maintain by per process wise. By using this, if you use the single table, then there will be some inconsistency. You see here, it's OpenOffice read till 501 byte. No, sorry, here OpenOffice actually wants to read next 501 byte. Here is 1001 byte because it's already read till 1000 byte. Okay, so this table you need to maintain by per process wise, not a system wide. Okay, this is why this entry should be the per process, and system wide open file maintain, you can say it is kind of shorter version of this file directory table, the files that already opened by several processes. All right, and most of the cases read write perform by using sequentially, but in some cases it may be random access. Sequential access means that it asks for first 0 byte, then 1 2 3 and so on. But random access, first let's say 0th byte, and then 1001 byte, and then let's say 3000 byte. Okay, this is how it's called, this random access, not a sequential order. Now let's see some other items. So this is for okay, let's do for some other thing, file operation. There are different kind of file operation. As we can say, one thing is called that creating a file. You know this by the, you always needs to create a file. This is the one of the operation of file. You need to always create a new file, and then also second things can be the let's say that reading a file. Once you create, you need to read, and then also another operation is you need to write the file, and then 4 is repositioning a file. Repositioning a file. What is repositioning a file? Let's say this is the SDD. And then this is the block number in here, block in here, block in here, block in here. So repositioning a file. So here is let's say byte. Here is store some byte in here. Here is store in byte for file. Okay. So if you go for the sequential order, this is 0 till 5011 byte in here, and 5012 till 1023 byte in here, and so on. 1024 till some others byte plus 512 in here. Okay. So this is how, if you go for the sequential order, you go for the sequentially, go and then you read it. But for this randomwise, so when you read this data in SDD, this is a mechanical part of SDD. In SDD, maintain a hard disk drive, maintain a, this is called this header, maintain a head. Head is nothing but a kind of clip type things, and it just move around in here. When it is sequentially, this SDD head is moved sequential order. Okay. This head doesn't require to jump around. Okay. But if it is now you see that if your SDD, if your CPU asks for the 0 number byte from this file, okay, 0 number it, then random access then it asks for, let's say, 3000th number of byte. 3000 after 0, then 3000, then let's say 3000 byte is in here in this block. So what you need to do, your SDD head, will be first, it will be in here, then it will be jumped to this place to read this 1000th of byte. Okay, 3000 of byte. Yeah, this things actually random access is this things is done by this performed by actually repositioning of a file. Okay, by repositioning file. Okay, this property maintain this random access of a file. Okay, in random access, your SDD head actually jump around one place to another place. Okay. Also, for in file, deleting a file, when you can delete a file in any time. So when you delete, it just remove every entry, also the file directory entry and everything. Another thing you can do, file directory table, and then you can do this truncate a file. When you go for this truncate operation, you just remove the data from this file, but file directory entry and file name should be there. Okay, only when you perform this truncate operation, then it just remove the data from the file. Okay, these are some common operation of file. All right. All right, now let's see that some operation for the contiguous file allocation method. Okay, some file allocation method we'll see now. Here. Let's see that. Okay, in here some file allocation. File allocation. File allocation. Okay, first file allocation is, we already mentioned that file. First we will see this contiguous allocation. Contiguous file allocation. But what is the contiguous file allocation? Let's see. This, if you consider this is SDD. This is the file SDD block. Okay, this is the SDD block. Let's say you have total file F1, F2, and F3. Let's say F1 is, let me red color. This is F1. F1 is stored in here, this block and this block. And next is F2. This is for F1. Next is, let's say, F2. Let's say F2 is stored in here, and here. And let's say this F3, file F3 is stored in some location in here. So these all are contiguous location. So this is contiguous location, contiguous file block in here. Also this F2 also is stored inside this contiguous allocation. Also, F3 is also stored inside this contiguous allocation. When this file is stored in a contiguous location, then we simply can see contiguous allocation. So this is very. So what is the advantages in this method? It is very simple, simple to implement, because you don't need to know about, if you know this first block number, where actually located this first block number for file F1, it is zeroth number of physical physical block. Also, what is the first zeroth zeroth block of F2 is located in 0 in 4-number block. Start this file F2, and F3 is start from at 9-number block. F3 is started. This is 4. This is 0 number starting 0 logical 0 block is stored in 0 number in here, and for F2 logical 0 block is stored in physical 4-number block in here, and 0 block for F3. F3's 0 number block is stored at the physical block number 9. Okay, if you know this information, then you can access this file as well. You can easily access this file, and then by using this number of block number, let's say here is how many number for this physical here. So for F1, you have how many blocks? 0, 1, 2, 3, total 4 blocks. So total number of block is 4. This is from 0, and total number is 4. So it should be total file should be 0 plus 4 till 4 number. If you sequentially read all of this till block number 4, till block 4, then you get all of this data for a particular file. Also, if your CPU request for a byte number that is outside this block number 4, let's say it's 5-number block for this file F1, from here you can see that easily decide that, okay, this block requesting byte is outside this total number of block of this file. So it is kind of invalid request by the CPU. You can make this assumption. Also another advantage is that its time taken is very less to read. If you read this file, actually it takes very less time, because it is in sequential order. So your SDT head can move actually smoothly from one block to another block to read this file. So read that is, of course, it is faster. But in case of let's say in case of actually non-contiguous allocation, let's say 0 block is in here, the 0-number block is file block is allocated in here. For file F1, 0 block is in here, and then let's say red color, 0 block is in here, and then let's say it's 1-number block is stored in non-contiguous location in here. Then your header, your hard disk head at first read this block, and then it needs to jump in this block. Okay, it takes time. Okay, jump is just, it needs to jump around, okay, ups, down, also somewhere, and this random jump is required for this head. So it takes more time if you consider the non-contiguous allocation. But most of the cases we use the non-contiguous allocation, we'll see later. Now let's see that another advantage is random access is very easy. Means that when you go for this random access, when you go for some random access from this file, let's say it's asks for here is 0th number block, let's say 10th number byte. So from here you can easily calculate this. Where is this 10th number byte is available, located here? You can go for 10th divided by 5, 12, and then you will get the point something, 0 point something. So it is floor, so you get the 0th number. So 0 number block you can access. Next, if it is asked for this, let's say 1000 byte, it is random access. After 10, then it asks for this 1000 number byte. Then simply again you will do this byte number divided by 5, 12, and then you will get this 1 point something. This is 1 number block. Or let's say give a big number. Let's say it asks for 10th byte first, random access. It gives the 10th byte first, then it asks for this, let's say 2000 byte. 2000 byte. Then what we will do? 2000 divided by 5, 12, then you will get 3 point something, 3 point something. So you will get this 3 number block, logical block of this 2005. Okay, 0 number logical block. Also, you know, the zero number logical block is stored inside the zero number block of uh, physical block number. So you just make a summation, the 0 number block plus this logical number, 0 number block of this file, and this logical number 3. So it will get this 3. So you just go for 0 till 3, you will get this. You will take this 3 number block to the RAM, and you can access this 2000th byte. It is very easy to calculate. Okay, easy to figure out this where actually the byte that CPU asks for, that CPU need to access, and its location. It is easily it can easily figure out in case of contiguous file location. Okay, file allocation. And then let's see that let's see what is the disadvantages for contiguous allocation. These are the advantages. So let me repeat it again. The advantages. First advantage is simple to implement, and read date take a less time than non-contiguous allocation. Also, random access is very easy compared to the non-contiguous file allocation. Now let's see what is the disadvantages for contiguous file allocation method. Okay, what is the disadvantages? So far we write this, we know the advantages of this file non-contiguous allocation. Now let's see what is the disadvantages for this type of allocation. First disadvantage is size declaration problem. First disadvantage is called size declaration problem. Size declaration problem. So what is the size declaration problem? Let's see, take the previous example. You have total 3 files, F1, F2, and F3. Also, you just allocate this you just allocate this for, this is for file F1. You just have this four block for this file F1. It is full, 4 file block, this 4 file block for this file F1. Now you open this file F1. And then you just add some text, because you can edit your file anytime. Okay, and then you add some text in file F1. Then what's happened? This size will be the increase. So so it needs to let's say it has previously 512 into 4. Okay, 4. It is this kind of byte. Now you are edit it becomes like, let's say it becomes 2050 byte. You just edit and 2 byte just increase. After editing this file, 2 byte is increased. Then how you can store this 2 byte? You see this this is contiguous allocation. This is contiguous allocation, and next block is already taken by this file F12 is already taken. So from here you can see that you cannot extend this file. Because this block is already full for 2048 bytes. This 2 byte you cannot store in the contiguous location, because this block is already taken by this another file F2. Also file F2 is from in here until here. Also file F3 also is from this place and this place. So let's say here is kind of some empty location, but you cannot store here 2 byte, because it is not a contiguous within this 4 block. So it should be, this 2 byte should be after this 3 block, at 4 number block. But 4 number block is already taken by the file number F2. So you cannot extend this file. This is called the size declaration problems. At the beginning of when you create a file, that times actually it makes, this create function call makes this block, okay, depending on the size of this block. But you don't know that don't know that tomorrow you will edit this file. What is the size of this file? You can edit this file, or you can delete some file. If it is deleted, there will be the hole, some hole. So you can delete this file, anything you can do. But you can, if you go for this edit, you cannot extend anymore. So this is the problem. Also at the beginning, you don't know this, what will be the size of your file. Well, at the beginning means that it means that you don't know that how many blocks is needed at the end, how many blocks is required for a particular file. Then you may go for this block is empty, and then store another block. You cannot, at the beginning you actually don't know that what is the size of this file. So this is the problem for this declaration size declaration problem. Once you set this file, if you edit it, you cannot extend it anymore, you cannot store it anymore. So this is one of the biggest disadvantages for contiguous file allocations. And next, another disadvantage, let's say now you edit. Also you can remove some data from this file as well. Remove some data from this file as well. Let's see once you remove this data, okay, before I start, let's say that if it is non-contiguous allocation, so you just add this 2 byte in your file. You just add 2 bytes in your file. So non-contiguous actually doesn't need to store this file in a contiguous location. It doesn't need to store in contiguous location. If you consider this non-contiguous location, this file byte can be this file F1 byte can be any place inside this hard disk block. So where actually you find this data, you can store it. So if you consider non-contiguous contiguous allocation, this size declaration is not a problem. So this is how actually non-contiguous prepared as a non-contiguous allocation. So you can extend, you can shrink your file anytime. Now next problem is for this contiguous allocation. Let's say you delete some data from this file. Let's consider from this file F1. From file F1, let's say file F1. Okay, file F1. And let's see, you don't have this block. So number 3 number. So number three, this is empty, kindly empty. It becomes empty. You just delete the 512 byte from this file F1. So this block is completely empty. Also, you delete some data from file F2 as well. So file F2, then let's say this 8 number block is empty. This 8 block from this file F2, you also delete the 512 byte. So this block becomes empty as well. And then you also delete 512 byte from file F3 as well. This block will be the empty. This block will be the empty now. So you have total 3 blocks. 1, 2, 3 empty blocks. Okay, there is no data in here. Now let's say you create a new file. You create a new file called, let's say, F4. It needs let's say 512 into total 3 blocks. Kind of like this amount of byte. So it needs total, let's say total 3 blocks. It needs total 3 blocks to store. So can we store this file inside this hard disk? Let's say we have total this amount of block. For example, this amount of block. We have total this amount of block. So here is, you see, here is total 3 empty block is available, but you cannot store this file because these 3 empty block, this block, let's say this block, these are empty block, but these are not in a contiguous location. So you cannot store this file, even though you have this 3 empty block is available inside this hard disk, but you cannot store it because this empty block is not in a contiguous location. So this is another problem. Even though empty block is available, you cannot use it. So this problem is also known as the external fragmentation problem. You already hear this external fragmentation problem previously. Fragmentation problem. This is from here you see this contiguous allocation, file allocation suffered by this external fragmentation problems. Okay, so if you consider this non-contiguous allocation, in non-contiguous allocation, file block can be stored any places. So you can store this, if it is non-contiguous allocation, you may store the 0th number block in here, and then one block in here in any location, and then one number, 0, 1, and then 2 number block is in here. So you can solve this problem by using this non-contiguous allocation. So by using this non-contiguous allocation, you can solve this problem. One of the major problem is called size declaration problem. Also the external fragmentation problem as well. And then what is the next problem? Next problem is, let's say you have a file. Let's say here is in a first file. In first file, you consider total number of how many blocks? 0, 1, 2, 3 blocks. 3 blocks. And sorry, total 4 blocks. 0, 2, 3. It's total 4 blocks, and it has total 2048 bytes. 48 bytes. Let's say it has this file. This file actually contains the 2000 byte. 2000 byte. So how many blocks is needed to store? Still, it needs to store this 4 block. So this block will be the full 0 number block will be the full storage, full, and in three number blocks, in 3 number blocks, what it will do? It is not a 48 bytes. If it is 2048 bytes, it will fill up this all bytes, but it is less than 2000 bytes. So it will store some. It will actually store some part. Most of the some part will be the empty. 48 byte will be the empty in here. 48 byte will be empty here. If file size is 2000 byte, if font size is 2000 byte, okay, then 48 byte from this last block will be the empty. So in this 48 byte, you cannot store this file f2 any other file you cannot restore. Okay, any other file you cannot restore. So this type of problem is called this internal fragmentation problem. Internal, because you cannot store the two different data in a particular in a same block. You cannot store that data from these two different files. Okay, this 48 byte will be the wasted. This is known as the internal fragmentation problem. Okay, these are the some problem for this internal fragmentation problem. But internal fragmentation problem, if you consider this non-contiguous allocation as well. So let's say this internal fragmentation, if you consider this non-contiguous allocation for this file f1 within 2000 byte. So let's say 0th byte you store in here, and then another block you store in here, then next it is stored in here, and 4th number byte 2000 byte is still there is kind of empty 48 byte. Okay, number 4 byte. Okay, if you consider any kind of file allocation, let's say contiguous, either non-contiguous, so internal fragmentation can be there. Okay, you can solve this internal fragmentation, but if you consider the non-contiguous allocation, you can solve the size declaration problem as well as the external fragmentation problem. Now let's see the last one of the last topic. Today's last topic is called this non-contiguous allocation. We'll see this linked list allocation method. Non-contiguous, it's called this linked list. Non-contiguous allocation method is kind of in non-contiguous, you know that you don't need to store a file in a contiguous location. So what you need to do in here is maintain a one method is called this linked list file allocation method. You are already familiar with the linked list file allocation method. So let's say file f1 it has, let's say, 1, 2, 4 block 0, 1, 2, 3 number blocks, and then here is the block of SDD. Zero, 1, 2, 3, 4, 5, 6, 7, 8. Block. Let's say this block is stored in some place called in here. So what it will do, it will maintain a linked list. This is 0 number block. This is non-contiguous allocation. So 0 number block it is stored in here. This is 0 number block. 0 number block is stored at the fourth block of hard disk. So then let's say one number block, where one number block is non-contiguous, it can allocate any places where actually there is a space available. Let's say one number block is stored in here. Here is stored this one number block. This one number block is stored in here, and then two number block. Let's say here is one number block. Two number block is stored in, let's say, in here. Here is two number block is stored in here, and then third block is stored in, let's say, in here. Okay, third block is stored in here. So 0 is here, 1 is here, 2 is here, and third number block is inside this here. Okay, so when you read this data, so how you can read this? So in here, if it is contiguous, it is not a contiguous location. If it is contiguous, then first read that one. If we get this 4, then okay. If it is 1000 byte, it should be that 5 number block. So, but it is non-contiguous allocation. It is not inside this adjacent location of a block. So during this read time, how we can do this? How we can do this? We have to maintain something called this linked list. If you go for this linked list, there are some type of others allocation method, non-contiguous allocation method as well. We'll learn later. But now let's see this linked list allocation method. What linked list allocation method will do? Linked list method will take the this is the data, and after this data there is a one pointer. It will link that where is this next block is available, where is actually next block is stored. So next block is stored in here, so it will point to here till this block. It will link this block, and then this block also. In this block, this is one number block. Here also it maintains this. Where is the next block? Where is the next block or two number block? So it will link to this two number block is here. So it will link in this place. Okay, and then this is two number block. Two number block will link this. Where is this third number block? Logical block is. So this is linked from here to this third number block. Okay, here is no link because only this contain only 4 blocks. So 4 block is linked. So this is null. Here is no link. From here there is no link. This is null block. Null in here. Okay. So when you read this data from a linked list allocation method, so in file directory table, you have this file name. Let's say F1. Also you have this location for this 0 number block. 0 number block is located at 4 physical block number 4. So if you get this 4 number block, and then from this 4 number block you can access this data, and if you get for this 1000th of byte, this is logical block number stored in logical block number. If you divide it in 512 byte, then it will be stored in logical block number 1. So from here you will find this. Where is the logical block number 1? So here at this 2 number physical block, the logical block is available. From this linked list, you can access this data from this 2 number block. And if you need to access this third block or logical block number 2, you will get this from this link to in here. It is 8 number block. You'll get it. And then if you go for this, if you need to access this third number block, logical block, or fourth block of logical number, so you can get this data from by using this link to in here. Okay, so this is how we can access. Any questions so far? So this is one of the simple method for this linked list. So let's see what would be the problem for this linked list Here is advantages. First, see what is the advantages. Here is no size declaration problem, because size declaration problems, you can store data at any places. If you edit data, wherever you find this actually hole, you can store it. So there is no size declaration problem. This is non-contiguous allocation. There is no size declaration problems. Also, there is no external fragmentation problems. Okay, in external fragmentation problem may happen then if there is a contiguous allocation, there is a constant for contiguous allocation. But here is non-contiguous allocation. So you can store data any places and just make a link from that place to the others for the other blocks. Okay, so there is no external fragmentation. But the problem is when you read this data, it takes time. Okay, it takes time from the 0 byte and then 100 byte. You read data operation. You actually SDD head actually moves ups down. Okay, there is only I saw there is only 3 rows, but there is million numbers of blocks. So it is always moves ups and down, but it takes read time. It takes time. Okay, it takes time, and then another problem is that random access file takes time. In case of contiguous allocation, I show you that if you go for this randomly access, it just added to the 0 number block. Sorry, 0 number. What is the location for the 0 number block plus the whatever the location for this logical block number for this whatever file actually asking for. It is 2000, so it will be the third number block. Third number logical block. You just add this 0th block plus third block. That 5th block, 7th block number, you will get it randomly access. But in case of non-contiguous allocation, if it is randomly accessed, 1000th number block is inside this third. If it is third block, so 0, 1, 2. Here, this block, in this block. So it is, you cannot actually make it only for the summation. 4 plus it is not 7, it is in 8, it can be different locations. So you can start from this 0th block and then link to the first block, and then you can link to go to the third block where is available. So you need to start from the 0 number block always if you go for this random access. So it takes time. Okay. Also, here you maintain this pointer. You know this. If you go for this pointer, so pointer is nothing but it maintains the address of the next block. So it always, if this is address, you maintain the address. So it's just waste some memory. Okay, you need to maintain this pointer. Okay. Yeah, of course the pointer takes some memory, so you need to maintain this address. So you need here actually there are some little waste of memory as well for every block. And then of course there is kind of as I mentioned that there should be a internal fragmentation, even though there is no external fragmentation, but internal fragmentation will be there in for non-contiguous allocation as well. Okay, so these are the some summary for this contiguous and non-contiguous allocation. Today we see this linked list allocation. In our next class, we'll see the file allocation method. So the file allocation method means file allocation table or FAT system for non-contiguous allocation. Okay. All right. Do you have any questions or comments for today's class, or anything need to clarify? All right. If not, then we can stop in here. Also today, I'll give you an announcement for you to extract edit. It is a report symbol, not symbol actually. You need to submit a report from 5 to 7 pages. So far that you learn. Okay. Thank you. Have a great evening and have a great weekend as well. See you next week.